Okay, so our video notes today are on geometric mean, and the geometric mean between two numbers is the positive square root of their product. This means that pretty much we multiply the two numbers, take the square root, that gets us our product, instead of the arithmetic mean where you add the two numbers together and divide by 2. So this geometric mean says when the means of a proportion are the same number, it is said to be the geometric means of the extremes. For example, in this case, 4 over 6 equals 6 over 9, so 6 is the geometric mean between 4 and 9. If we're just dealing with numbers, we'd set up a proportion similar to this one. So we could say 5 over x equals x over 45. Notice how up here 6 is on the bottom of our first fraction and on the top of our second. So when we set up the proportion here, x should be on the bottom of the first one, on the top of the second one. So here we would have 5 times 45, which will equal 225 equals x squared. We now take the square root of both sides. So the square root of 225 is 15. So 15 is the geometric mean between 5 and 45. We could do the same thing here with 12 and 15. So you'd have 12 over x equals x over 15. 12 times 15 is 180 equals x squared. When we take the square root of both sides, we could get 6 square root 5 is equal to x. We have a few other ways we could ask questions about this. We could say 10 is the geometric mean between 5 and what number? So how we would write this out? We would say 5 over 10 equals 10 over x. So we would cross multiply like we often do, and we would get 5x equals 100, and then when we divide both sides by 5, we could get that number we're looking for is 20. So we could do something similar with number 4. So it says 12 is the geometric mean, so it means 12 will be on the bottom of our first fraction and on the top of our second fraction. So where this 16 goes, 16, since it's bigger than the mean, 16 will go on the bottom of our right fraction. You notice how on the one before, 5 went on top because 5 was less than the mean. We can put our x above 12 over here. So we get 16x equals 144. If we divide both sides by 16, we get x equals 9. So our next piece is dealing with geometric means and right triangles. So we should remember that an altitude is a segment from one vertex of a triangle and is perpendicular to the opposite side. So when the altitude of a right triangle is drawn from the right angle to the hypotenuse, there is a special relationship created. That relationship says the altitude drawn to the hypotenuse of a right triangle forms two similar triangles that are also similar to the original triangle. Here we'll write out a similarity statement for the 3 similar right triangles. So our first big one, we're going to call that triangle ABC. ABC is similar to, I'm going to deal with this middle-sized triangle now, ABC. So we went along the hypotenuse and then along the shortest side is similar to triangle ACD. And then both of these triangles are also similar to our final triangle, which would be CBD. So if we separate these out into the three similar triangles, the largest one, the middle one, and the smallest one, we could write proportional statements for each of the sides with any of the other triangles. But one thing that we have that's helpful is the geometric mean altitude theorem, which I will show you in 1 second. So we call this method to find the geometric mean, and this is usually used to find the hypotenuse when we know what x is and we know what y is. We can also use this when we're looking for either x or y and we know the hypotenuse. But how this works and why it's called the heartbeat method is because we take our x and we put it over the h, and then we take h again and we put it over our y. So our proportion would look like this: x over h equals h over y. Okay, so this geometric mean leg theorem, which we usually call the Nike swoosh method to find pieces and to set up the proportion, says that the length of a leg of the triangle is a geometric mean between the portion of the hypotenuse adjacent to the leg and the entire hypotenuse. So, for instance, in this case, if we want to find b, we could say that x over b equals b over this entire hypotenuse. It looks kind of like the Nike swoosh if we connect it all up. And in this case over here, if we're looking for a or y or any of that, so we have this, we take y, we put y over a, and then a over the entire hypotenuse. So this proportion would be set up as x over b equals b over x plus y, or c is that entire hypotenuse. So it could be over x plus y or c, whichever one they give you. You may have to calculate it, you may not. In this case, this one is y over a equals a over x plus y, or again, you could have c as your bottom here. So in this example, I'll show you how we could find x, z, and y all using different pieces here. So our methods we showed previously both use the triangle where the hypotenuse is on the bottom. So if you would like to turn the paper, that's what I'm going to do now. So our first one, we're going to talk about how we could find x. So x, since it's on the side and we have information about the hypotenuse, we would use that Nike swoosh method. So for x, we would take 8, put it over x, and then x over the entire hypotenuse. So this would be 8 over x equals x over 8 plus 25, which 8 plus 25 is 33. So in this case, when we would write this all out, this would be x squared equals 8 times 33, which is 264. X squared equals 264, and then we can take the square root of both sides to find x. I think this would just end up as x equals 2 times the square root of 66, which we could find out a decimal approximation for if you wanted to. So if we were to find y, we could also use this Nike swoosh method. We would do it starting at 25, so 25 over y equals y over the entire hypotenuse. So For this case, we would have 25 over y equals y over 33. So if we multiply this all across, we would have y squared equals 1,275. So we take the square root of both sides. Y equals 5, the square root of 33. Again, we could find a decimal approximation for that if we would like. Our final one would be finding z, and to find z, we would have to use our heartbeat method. So we would take 25, heartbeat up to z, put z on the top, and then back down, and include 8 on the bottom. So 25 over z equals z over 8. So in this case, 25 times 8 is 200 equals z squared. So when we take the square root of both sides, we get 10 square root 2 equals z, which again, we can find a decimal approximation for if we would like. Thanks. See you guys in class on Friday.